Welcome to Cloud on Air, live webinars from Google Cloud. Today we're hosting webinars every day. My name is Dustin Smith, and today we'll be talking about 10 tips for building long-running clusters using Cloud Dataproc. I'm really excited because I'm joined by my friend, Michaela Const. Hi, Michaela.
Hi.
So before we get started, I wanted to let everyone know you can ask questions anytime on the platform, and we have Googlers on standby to answer them. So let's go ahead and get started. So as we're talking about 10 tips for building long-running clusters using Cloud Dataproc, our agenda is very much focused on giving a quick overview of Cloud Dataproc, what it is, why we have it here at Google Cloud. We're going to be talking about ephemeral clusters versus long-standing clusters. And then we're really going to get into Michaela's favorite topic, which is 10 tips for long-standing clusters on Google Cloud. And then we're going to do some live Q&A at the end. So let's go ahead and get started and talk about Cloud Dataproc itself. Cloud Dataproc is Apache Hadoop and Apache Spark on Google Cloud Platform. And the idea is to really reimagine what is possible when we think about using those technologies. If we look at Cloud Dataproc as a product, very much focused on being that fully managed Apache Spark and Apache Hadoop service, rapid cluster creation, all the familiar open source tools that you might be used to using in a Hadoop environment. The idea that because this is the cloud, you can use customizable VM resources. You should have the flexibility to create that compute infrastructure that you want to use. The ability to create ephemeral clusters on demand. And I know we're going to spend some time talking about this today, but just very quickly, rather than the idea of having one large cluster, the idea that you could have a big cluster, a small cluster, any kind of size cluster that you want, spin it up, complete the jobs you want, and then spin it down. It's that ephemeral concept. And then most importantly, Cloud Dataproc tightly integrated with other Google Cloud Platform services, whether that's analytical or streaming data or storage or transactional resources. When we think about common Spark and Hadoop clusters, especially as we think about and talk with customers that run them on-prem, we hear a lot about, well, scaling clusters can be really difficult. Obtaining servers, configuring servers, installing OSS, and then the reconfiguration conversations around configuring OSS and optimizing and debugging and then processing data to get to where you want to be. And what that ends up creating is a lot of pain, especially on the enterprise front, where just to scale those up, right? When we have successful clusters, these things still happen. Over time, it takes, whether I have to buy those servers and install them and get them ready to go, the utilization conversation. I always have to have that cluster ready to go 24/7 for peak usage. What that means is kind of peaks and valleys, because I then have these long periods of inactivity. Customers tell us that is not great for us because, at least the last thing, which is cost pain, is I have to have a huge outlay of cost just to have this cluster up and running, and then it uses itself sometimes, but then not others, and then over time I carry that cost forward and it scales. And so as we think about these big pain points when running especially traditional Hadoop and Spark clusters, Google Cloud Dataproc's vision is very much focused on fast. So when we say fast, we're talking about spinning up clusters in an average of 90 seconds. And I'm not talking about 3 or 4 nodes, I'm talking about clusters with hundreds of nodes. We're thinking about easy, whether that's using things like workflow templates and initialization actions, which we're going to talk about later on in the webinar. Our goal is that it's not just that your cluster is up, it's that your cluster is useful in a fast way. But then most importantly, cost effective. So Google Cloud Dataproc being billed on the second, paying only for what you use, right? Again, fast, spin up, spin down, keep it up as long as you need. And then we talked about that customizable compute infrastructure. That includes things like preemptible VMs, the ability to get an 80% cost reduction by using VMs for non-critical workloads that maybe could disappear, as you're working through a workload, but then come back. So we've talked a little bit about Cloud Dataproc. Before we get started on the 10 tips, Michaela, can we talk a little bit about the difference between ephemeral versus long-standing clusters?
Yeah, sure.
Awesome. Well, give me a quick overview, and I'm just going to stop for a second.
Yeah.
Michaela, what team do you work on?
I work on Cloud Dataproc.
Awesome. And I'm the product marketing manager for Cloud Dataproc. You're on the software engineering team
Yeah.
for Cloud Dataproc, and we're best friends, and this is awesome. Let's talk about ephemeral clusters real quick.
All right. So ephemeral clusters are great if you're running like batch jobs. So I guess if you want to spin up a cluster, run a job or a workflow of jobs, and then tear down the cluster and have your cluster just scoped to your job, then ephemeral clusters are probably a good fit for that.
And this is a pretty dramatic shift in paradigm as we think about, again, that traditional Hadoop cluster idea of one big cluster that you run all of your jobs in, this shift to being able to say, you know what, I'm going to create a cluster per specific job. Even the size and what the components in that cluster can be tailored, correct?
Tailored to the job, yeah.
Awesome, very cool. So then we think about that in the concept of, well, if I've got ephemeral clusters, why would I ever want a long-standing cluster?
So that's a good question. So yeah, ephemeral clusters are great for batch jobs, but like not everything's a batch job. So if you want to be more interactive with your cluster, so if you want to like use a Jupyter notebook or Zeppelin notebook to do some like ad hoc data exploration type stuff, then a long-running cluster might be a better fit. Or if you want to run streaming jobs, or actually a really good reason to use long-running clusters is if you have like a lot of kind of similar shaped jobs that all require like, I guess, the same type of cluster. And then you can have multiple users like sharing one bigger cluster and submitting lots of jobs at once.
Awesome. And that use case right there, where we're talking about lots of users potentially submitting a lot of jobs, what we're looking at on screen here is the idea of starting with a small cluster and then users submitting jobs. Step number 3, I know we're going to talk about it later, but what's happening in step number 3?
Yeah, so actually we have a new feature called auto-scaling that's in alpha right now. And so as users are submitting these jobs, the cluster can scale to meet the demands of these jobs that are being submitted, and then as usage might decrease throughout the day, the cluster can scale down.
That's awesome. And so when we think about Cloud Dataproc and we think about the problems we were talking about earlier around the utilization valleys, right? This is really meant to address the customer pain that we hear a lot of people saying, I don't want a big cluster up all the time, right, if it's not being used. Well, cool. So let's get to the fun part. So you've got 10 tips for our friends out there around building long-running clusters using Cloud Dataproc. So tip number 1 is using Google Cloud Storage as your primary data source and sync. Now, wait a minute. I thought we were talking about Cloud Dataproc. Why is the first tip about Google Cloud Storage?
Yeah, so when you're using Cloud Dataproc or just any cloud product, a really good thing to think about when you're starting your cloud migration is separating your storage from your compute.
Okay.
So this makes sense, first of all, because it's cost effective. So you don't want to be paying for a whole bunch of compute that you're not really using. That's just like sitting there just to serve HDFS data on your cluster. So it makes sense to pull the data off into GCS, Google Cloud Storage. And then the second reason this is an important thing to talk about in the context of Dataproc is to unsilo your data. And so what this means is when you're probably used to having your data in HDFS on your cluster, but it kind of like limits the usefulness of that data because it's restricted to that cluster. It's a good idea to pull it off into Google Cloud so it can be used not only by other clusters, but by other Google Cloud products like BigQuery or something.
Got it, got it. And so the reason this is number 1 is as we think about that paradigm shift of I run everything in one cluster, therefore everything needs to be in my cluster, like including my data. This is a fundamentally, well, no, actually, if you think about it, if you store the data on GCS, right, especially in the unsiloing your data conversation, we might be running analytical workloads in BigQuery, we might be doing machine learning type things, right, CMLE or other things. Putting your data in GCS makes that integration really, really easy as opposed to having it clustered on, and siloed in HDFS. Okay, number 2. Persist information on how to build your clusters. Talk to me more about this.
Yeah, so on an earlier slide, we were talking about how sometimes it can be frustrating to get the configuration exactly right for your cluster, and there's like a lot of like maybe manual setup you have to do even once your cluster is up. And so we have several ways to kind of eliminate this frustration by persisting this information about how to build your clusters. So the first way in which you can do that is using what's called an initialization action. So initialization actions are just scripts, and you can write the scripts, or we actually have a GitHub repository of some pre-canned scripts that you can use to like install different software or configure different things. And we, Dataproc, will run these scripts on your behalf when the cluster starts up so that it's ready to go when you are.
Awesome, huge cost savings, or time savings and cost savings on that, cool.
Yeah. And so the second way in which you can do this, so initialization actions are great, but sometimes you need a little bit more flexibility. So what you can do is build what's called a custom image on top of a base Dataproc image that we provide, so that this is actually good because it can save you time. So like the initialization actions will like add to your cluster startup time, but if you do whatever you do in the initialization actions in a custom image, then you're saving time on cluster startup.
Interesting. Okay, that's good. What's the third tip?
Yeah, so the third tip is actually, so you're probably used to, when you set up your Hadoop cluster, configuring a whole bunch of properties and like tuning it exactly right, which can be kind of a pain. And you don't want to have to like remember all the properties that you set and like do that every time. So what you can do is actually export the configuration of a cluster, which actually includes, we talked about different like VM types and things earlier. It includes information about that. You can export that configuration to a YAML file using this gcloud export command. So then that YAML file can be reused in the future. So you've finally got your running cluster that you like, you love this cluster, and you say, I want to do this again. So you export the configuration of that cluster to a YAML file and then use that to create another cluster.
Awesome. So 3 different ways to effectively save time, save money early on, get your clusters exactly the way you want them, whether you have one big long-standing cluster or a bunch of ephemeral clusters, or both, because you can have both, right?
Yep. Oh, for sure.
Awesome. Best of both worlds. I love it. Tip number 3, identify a source control mechanism. What is a source control mechanism and why do we care about that?
So usually, I mean, if you're writing just like regular Java code, you'd be like crazy to not use a source control mechanism. So you should also do that for things that you might not think about as code as much. So if you're used to like on your on-prem cluster, I guess, running a bunch of queries, or you might have like a bunch of Python scripts or Bash scripts or tools that you use, I guess, and you're used to doing all that on your cluster can kind of become this like repository, and you don't want that to happen, I guess. So it's a good idea to pull that stuff, all those tools, off of your cluster into some sort of source control mechanism. So there's lots of different options for what you can use for this. One recommendation that we have is using cloud source repositories. So this is something that Google Cloud offers. It's basically just Git repository hosted on Google Cloud as like one option you could consider.
Very cool. Okay. And again, there seems to be like a little bit of a theme here, which is all the things you thought about only running inside a singular large cluster, maybe think about taking that off of the cluster and leveraging other tools to do that, right? So it persists ongoing. Okay, let's see. When we think about tip number 4, externalizing the Hive Metastore or database with Cloud SQL. You like this topic, don't you?
Yeah, so I actually helped write a different blog post about this topic. So I can talk about it a little bit. I guess I can talk about what Hive is first. So Hive is basically just like SQL on MapReduce or SQL on Tez, like whatever execution engine you want to use. Basically, how Hive usually works is you have your like data warehouse like in HDFS. But a good idea is to pull that off of your cluster into GCS. So that's why that was tip number 1, pull things off into GCS. But then also you have your Hive Metastore database. So this is like your metadata, your data about the data, and you want to pull that off. So usually on your cluster, this is in like a local MySQL database, but that's kind of unfortunate because then when your cluster goes away, your database goes away, which you don't want. So you can pull this off the cluster into what's called a Cloud SQL instance. So this is like another cloud product we offer. A Cloud SQL instance is basically just like managed MySQL. So you can point your Hive Metastore server at not a local MySQL database, but this like Cloud SQL instance.
Got it. So yet again, if a cluster ends up going away, right? We've talked about putting things in GCS and source control, and now with Cloud SQL, again, you get all the benefits of that ephemeral or long-standing, but you've got all the things around it that doesn't matter if the cluster's up or down.
So, and even for long-running clusters, this is useful because all your data can be in one place, so it can be shared among multiple different clusters.
Got it. Good to know. Very cool. So when we think about tip number 5, use cloud authentication and authorization policies. How does this relate to long-running clusters?
Yeah, so with long-running clusters, or any clusters really, you can configure like a few different levels of authentication. So I guess I'll zoom out a bit and talk about like the highest level of permissions you can configure. So you can configure like IAM permissions, and you can do this on the cluster level or the job level. So you can say like, I grant these users cluster create permissions, I guess. And actually you can do even more than that. So we have something called granular IAM permissions, and you can use this to say, actually, I only want to allow these users to submit jobs to this cluster. So you can get like a finer level of control there.
Okay, and so especially as we think about, people are used to having a single large cluster, and the authentication for that is effectively the authentication for everything. And as they come into the cloud, as they come to Google Cloud, right, our encouragement here is to think about, well, especially if you're going to have multiple clusters potentially, or be using multiple services like GCS, right? You may want to leverage something like Kerberos. Absolutely think about that, but think about it from a broader standpoint than just any one cluster. Awesome, awesome. All right, tip number 6, know your way around Stackdriver. Michaela, what is Stackdriver?
So Stackdriver is a few different things, actually. One of the things that Stackdriver is a logging system. So it's a way that you can externalize your logs from your cluster onto the cloud so that you can see all your logs in one place. So these might be like the logs for the different daemons running on your cluster. So your resource manager logs, your name node logs, or whatever logs. We'll automatically export those to Stackdriver on your behalf. And then the other way in which Stackdriver is useful is for monitoring. So you can use Stackdriver to export metrics about your cluster. So we actually automatically export some metrics for you. So some basic like yarn metrics and HDFS metrics. But if you need more than that, you can actually configure your own custom metrics to be exported to Stackdriver. And this is really useful because, again, if you have like several long-running clusters, you can see all the logs and all the metrics from these clusters all in one place in Stackdriver.
Got it. And again, where customers are thinking about only using maybe a yarn interface or something like that to monitor just one cluster, this is that ability to look at multiple clusters and see a lot of other stuff. And there's more than just Dataproc information that can go into Stackdriver, obviously.
Oh, yes.
Which is great.
Yep.
Tip number 7, so transform yarn queues into workflow templates. What is yarn?
So yarn is yet another resource negotiator.
Love it.
Let me first talk about like what even is a workflow template, because this might be something that people are not very familiar with. A workflow template is a way to define like a graph of jobs that you want to run. So your jobs might have dependencies on each other, so you might want to lay them out in a graph that you can run. So a workflow template is like a first-class resource that allows you to do that. So you can run a workflow template on a cluster. So there's 2 different ways to do this, actually. So one way, which is the classic way in which we think of workflows, is you would spin up a cluster, run the workflow on that cluster, and then tear down the cluster. So have the cluster just be scoped to the workflow. But actually, what I'm going to talk about is how workflow templates are useful in the context of long-running clusters.
Okay.
And how this relates to yarn queues, which is how we got here. So yarn queues are typically used as a way to, I guess, like silo resources, I guess. A way in which you can use workflow templates for the same purpose is that workflow templates actually, you can configure something called a cluster selector. And what this is instead of submitting work to a particular yarn queue, you would submit work to a particular cluster. So you can actually say, only run workflows on clusters that have these specific labels. So when you create a cluster, you can label it. You can give it labels that say, this cluster supports running this types of job or workflow or whatever. And then when you submit the workflow, you can say, submit this workflow to a cluster that has these properties, I guess.
So you don't even need to be specific about which cluster.
Exactly. So you can actually set up like a cluster pool, let's say. Let's say you create like a whole bunch of different clusters that all have the same labels, and this is your cluster pool that you want to draw from for like this type of workflow or whatever. So when you submit the workflow, we'll actually pick out a cluster, not only based on those labels, but on like the usage of the cluster.
Really?
Yeah.
So this is really interesting because as you think about yarn, as you think about like that is what a cluster administrator might be used to monitoring and queuing up resources, as we're now saying, hey, think about multiple clusters. Maybe I've got a bunch of ephemeral clusters or what could be ephemeral clusters and a long running cluster. You're actually saying, rather than think about yarn queues, think about workflow templates as a way to line up, but then also be the arbiter of where that goes.
Yep.
And it's not even which specific cluster, it's just you've identified types for jobs and it does that for you. That's a huge overhead cost savings. Okay, that's pretty cool. Tip number 8, start small and enable auto-scaling. So I know we already talked about auto-scaling a little bit, but let's talk about it again.
Yes, for sure. So it's an exciting feature. Right sizing your cluster to your job is a big challenge, I guess, a lot of the time. So instead of spending a bunch of time trying to figure out exactly how to right size your cluster, what you can do is start with a small cluster and enable auto-scaling. So when you submit jobs, the cluster can scale up automatically. In order to make decisions about how to scale up, it actually uses those same Stackdriver metrics that we were talking about earlier. So like,
got it.
It'll make decisions based on the yarn metrics.
Got it. So if we took a use case where a company has come to us and our customer is saying, hey, we're going to be using a cluster for data science, right?
Yep.
And we're going to start with a small cluster, but we expect that depending on what's happening, we've got this long-running cluster. We may have a lot of data scientists submitting a lot of different jobs. we don't want to be in the business of watching it and saying, okay, add more, add more, add
Yep.
more. Based on the metrics that Stackdriver is receiving, the auto-scaling feature can automatically just,
Yep.
awesome. That's a great use case. Tip number 9, consolidate job history across multiple clusters. Talk to me about this one.
Yeah, so whenever you run a job, so like a MapReduce job or a Spark job or whatever, it writes some history to a file, and usually this file is stored in HDFS on your cluster. But a downside of this is, again, when your cluster goes away, the history goes away, which is not great. So it's a good idea to externalize your job history and put it in GCS. And another benefit of this, so even for long-running clusters, like even if your cluster is not going to go away anytime soon, it's a good idea to have all your job history in one place in GCS so you can analyze it all together, I guess, as a whole. Yep.
Very cool. And I'm seeing the words override the MapReduce done directory and intermediate done directory.
Yeah.
This sounds scary and complicated.
Yeah.
Is it scary and complicated?
No, it's not scary and complicated at all. So when you create your cluster, you just set these 4 properties to point at your history bucket. And if that's too much work for you, then you can just use one of those YAML configuration files that we talked about earlier to just say, like, okay, every time I create a cluster, I just want to set these 4 properties. Like,
so you're saying this is like a one-time, 2-minute activity, and you never do it again?
Yeah.
Oh, okay. So that is not scary or complicated. I love it. All right. And tip number 10. Take advantage of GCP services. This is kind of the big one, right?
Yeah.
What do we mean by this?
Yeah, so when you first start your cloud migration, like onto Cloud Dataproc, you start with kind of like a lift and shift, and you just try to figure out, okay, how do I do the same things that I was doing on-prem on a Dataproc cluster? But once you're comfortable with that, you might want to start thinking about kind of pulling away from like this monolithic cluster model where like everything you ever care about ever is on your cluster. And again, like start thinking about how can I externalize some of this software and some of this behavior outside of the cluster. So for example, like if you're used to running Hive queries on your cluster, you might try out Cloud BigQuery.
Interesting. Okay. And so I like what you said where, again, many people come to Dataproc and they say, I'm used to running all of these things inside of my cluster, right?
Yeah.
Some of them might be analytical workloads using Hive, right? And you can absolutely do that on Dataproc. In fact, tons of people do that.
Yeah.
But over time, they might look at that and say, actually, there's another service that now that I'm inside of GCP, Google Cloud Platform, it's right there. My data is centralized in Google Cloud Storage already. There's a serverless interface I can use with Google BigQuery. Why don't I try that? And suddenly, you're actually taking something that used to only run inside of a Hadoop environment in Dataproc and now using a different service. As we think about that data science workload that we talked about earlier, maybe that cluster, they were solving a lot more than just data science stuff, right? And they were dealing with cluster constraints. You're saying that in this scenario for a long-running cluster, we may keep a cluster. The customer may say, we got this cluster in Dataproc, it's doing all the things it did before. We're actually going to keep that data science use case for this cluster and tune it accordingly, auto scale up and down. But these other things, maybe it's a transactional workload. Maybe it's, there's tons of things you can run inside of a Hadoop cluster. People over time start to kind of say, oh, well, there are other services and products that Google Cloud Platform does that maybe I don't have to think about this in only a Hadoop framework. Got it.
Yeah.
Okay, that's pretty cool. And that's actually an interesting way to think about, again, that paradigm shift of my world is only one cluster, my world is only Hadoop, to actually think, well, now my world can be multiple clusters, and even it can be outside of Hadoop altogether, potentially. Very cool. Okay. Well, thank you for joining us. Before we leave, I want to direct everyone to the blog post that Michaela actually wrote that has a ton of additional details. It's the same topic as this webinar. The URL is up there as the number 1. If you're interested in learning more about Dataproc, and you should be because it's really, really cool, hang out and check out the tutorials that we've got. We've got the URL up there as number 2. Like we said, clusters spin up really fast. The tutorials are really concise. So in 15 minutes, you can actually get a really interesting walkthrough and get your fingers on keyboards for using Cloud Dataproc. And then number 3, if you want to learn more about customers who are currently being successful with Cloud Dataproc, we've got a URL up there for you to see some customer stories. So now we're going to go to Q&A. Please stay tuned for a live Q&A. We'll be back in about 1 minute or so. Awesome. All right, welcome back. Let's do some live Q&A. You ready, Michaela?
Yep.
Okay, we've had some questions come in over the course of the webinar. And I'll start with the first one. What should I do if my Hive metastore needs to be shared by clusters in different regions?
Yeah, so this is actually kind of a complicated use case, but what you want to keep in mind is that your Hive metastore server should be co-located in the same region as your Cloud SQL instance. That's important because they're rather chatty, I guess, versus your Hive server 2. So I guess go back a little bit. So how Hive usually works is when you submit a Hive query, the client talks to the Hive server 2, Hive server 2 talks to the Hive metastore server, that uses the Cloud SQL proxy to talk to the Cloud SQL instance. It's a little complicated, but usually this all happens like on the same cluster, but what you can do actually is have a cluster or a few different clusters that are just dedicated to running a Hive metastore server and have those be like co-located in the same region as your Cloud SQL instance, and then have your other clusters, which are in a bunch of different regions, have those run your Hive server 2. So you'd submit your queries to those clusters, but they would use the Hive metastore server that is in the same region as your Cloud SQL instance.
So totally achievable, right?
Yeah,
Got it. Okay. I've got another question coming up here. How can I view the job history for jobs from different clusters together in the same web user interface?
Yeah. So we talked about earlier how you can offload your job history from the cluster onto GCS, and then if you do that for all your clusters and use the same GCS directory, you have all the history all in one place. But now it's like, well, how do I actually view this job history? Like, I want my pretty UI, I guess. So what you can do for this actually is we have a feature called single node clusters, which is what it sounds like, I guess, a cluster with one node. So you can create a single node cluster that sole purpose is basically just to like run a job history server. And there's instructions for setting this up in the blog post actually, but you can use a SOX proxy, I guess, to view the web UI for that job history server. And since that job history server points at your bucket in GCS, where like all your shared job history is, you can actually see the history like in the UI for multiple clusters all in one place, which is really neat.
Got it. Cool. Awesome. Let's see, another question. Can I trigger Dataproc jobs or workflows in response to external events?
Yeah, so this is actually a really good example of how Dataproc integrates really well with other cloud services. So there's a couple different products, Cloud Functions and Cloud Composer, that Dataproc works really well with. So you can use Cloud Functions to like trigger actions in response to events like let's say something changed in a GCS bucket somewhere, and you want to like run a job in response to that or something.
Okay.
That's something that you can totally do with Cloud Functions. And then you can use Cloud Composer, which is kind of like it's like a workflow orchestration framework, I guess. It's built on Apache Airflow, if you've heard of that.
Got it.
So you can use that in combination with Cloud Functions to set up like a Dataproc job or workflow or creating a cluster in response to an event. So we actually have like Dataproc Airflow operators, and you can submit your own operators too.
So this is a pretty common occurrence.
Yeah.
Got it. Got it. Another question. When should I use initialization actions versus custom images versus optional components?
Yeah, so all these things kind of play like a very similar role, so I can try and tease this apart a little bit. So optional components, I think maybe we briefly touched on, but I can talk about it a little bit. So this is a relatively new feature where I guess we had like a Kerberos optional component or Jupyter or Zeppelin optional component, and it's basically just like checking a box like I want this software on my cluster, and then we'll figure it out for you. And usually like how something becomes an optional component is it'll be an initialization action. We'll see like, oh wow, like a lot of people are using this. Like this seems like something that people really like, and then we like kind of migrate it into this fully supported like optional component. So if you want to use a piece of software that is an optional component, that is the route you should go.
Got it.
But if you need to install some like custom software or have some like custom configuration set up, then initialization actions are good. But like I think we touched on earlier, custom images are really good. It's kind of more complicated to set up, but it will save you time when you're creating a cluster because you don't have to wait for all those initialization actions to run. All that software is just baked into this custom image and just ready to go when the cluster starts.
So especially if you know downstream you're going to be doing that a lot,
yeah.
just and you're good to go. Got it. Got it. And I think we have time for one more question. How does Dataproc determine when it should auto-scale a cluster?
Yeah, so we touched on this earlier a little bit, that it uses yarn metrics, but specifically how it works is it bases it on yarn pending memory and yarn available memory.
Okay.
So if there's a good amount of yarn pending memory, we might say, oh, we should scale up the cluster in response to that. Or if there's a lot of available memory, we say, oh, okay, maybe we should scale it down. And I guess like you can configure how aggressive you want the scaling to be too, because like, yeah, it's something that you want to tune and play with a bit. And you can also configure stuff like, I know we mentioned those preemptible VMs earlier. So for auto-scaling clusters, you can actually set kind of like a target ratio of preemptible VMs to primary workers.
Oh, so you can actually mix and match a little bit between like how many inside of a cluster are preemptible versus.
Yeah.
Oh, interesting.
Exactly.
Okay.
Yep.
Very cool. Very cool. Well, we are running out of time, so we're going to have to say goodbye. But first, let me say thank you to my friend Michaela. Awesome. Thank you for tuning in, and please visit the Cloud On Air to discover more content from Google Cloud experts. Have a great day, everyone.